No computer has ever been designed that ever knew what it was doing. But then again, neither do we. Hey guys, it's Doug. I want to know how you feel about AI, whether you're a consumer of AI or you're a creator of it. Personally, I'm torn. There's a bunch of different parts of AI that are really exciting, but some of them just fall flat. First, let's talk about the things in AI I'm not really pumped about. Then in the second half, we'll talk about things that are really exciting to me in AI as a consumer and as a creator. In this video, I'm purposely avoiding the moral arguments for or against AI. But just to get us on the same page, when I talk about AI, I'm talking about the whole shebang. It's important to keep this in mind because there are specific categories in AI that are smarter than other categories. Some parts are great, but other parts are just kind of meh. You can throw a stick and hit a dozen CEOs and startup founders who are all talking about how they're innovating with AI and ML right now. But what they're really saying is that AI and ML are really great marketing terms that they like to use, and that eventually they'll catch up and maybe implement something. Right now, I think AI and ML specifically are just really overhyped in the tech space. The terms are used way too loosely. Unlike TV shows would have you believe, most AIs are not autonomous. Successful AI projects require humans to handle the inputs and the outputs. And the AI field is difficult, but not for the reasons you might think. It's not always super complex as it is about getting the right data for the problem. Experts in the field of AI think that as much as 85 to 87% of AI-related projects will either fail completely or they'll fail to solve the problem they set out for in the first place. So here's some examples of types of projects that I think are just overhyped. The prescriptive model used in some AI projects is just like a giant if-else condition, where they have a bunch of inputs and they try to determine hopefully the right answer given enough if conditions that they derive the right solution. We're all familiar with the COVID symptom checkers, where you type in whether or not you've been exposed to somebody, if you're feeling any symptoms and things like that, and then it tells you whether or not you should get tested or consider getting a vaccination. Think of these models as though they just knew that stuff about you automatically, or they could see your medical chart, and then it goes through this giant if-else tree, and when it comes out the other end, it says, you should get tested or you should not get tested. Like, that's really all it is. They're really not that smart. It's just a bunch of questions that were designed ahead of time that can be run through in an automated fashion. Another type of AI that I think is really overestimated is the type of Hive AIs. Now, if you've been watching Hunter x Hunter like I have, you're probably done with hives for now, but hear me out. Let's do a simple example like using an immune system, like white blood cells and a virus cell. In this case, each of the actors, so the white blood cell and the virus, each have their own really simple set of rules that they follow, and when applied to a single cell in this case, it really doesn't seem like it's all that smart, but when you apply those behaviors to a really large number of things that are all interacting in the same space, you can observe some behavior that looks smart. So what ends up happening is that when you have a single white blood cell and you have a single virus that these rules are applied to, they really just don't seem that smart. If you place them randomly on some board and you run this iteration a bunch of times, they just sort of jitter around until eventually, statistically, they'll likely come across one another and begin this sort of game of cat and mouse across the board. But now, let's say you put a bunch of those virus and a bunch of the white blood cells all on like a checkerboard. What you'd end up seeing is that all of the white blood cells would start to sort of group together as soon as one cell detects that there's a virus nearby. You see this behavior making it look very smart when it's applied at scale, but in reality, it's just a bunch of really simple commands that aren't really all that smart. Now, moving on to the next thing, neural nets are pretty exciting when they're done right. But in order to make a good model for a neural net, you need to be passionate about a specific problem. You need to be able to look at the problem from all different angles and build a really good model and reinforcement training strategy for that model. To be honest, I think that gathering the datasets and applying proper data science is more difficult and more important in training AI than the actual computer science behind the AI itself. Take an example of a really famous AI. We have IBM's Watson. So Watson was trained and successfully beat Ken Jennings, the world-class Jeopardy player, at his own game.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right.
So you'd think that Watson is really smart. So let's try to apply it to other problems. If it can beat Ken Jennings, What else can it do? Back in 2018, scientists tried to train Watson to create treatment plans for cancer patients. The initiative ultimately failed because they used too small of data set to apply good best practices. And secondly, they found that teaching Watson how to read the charts just like a doctor would proved to be almost impossible. And this just goes to show that AI is not smart enough to solve problems on its own without human supervision and controlling of inputs and outputs. Usually, the creator of an AI, they create the solution to the problem first, and then they try to use AI or ML or neural nets to try to recreate and solve that problem at scale. So really the only way to have a successful AI project is to combine your technical skill with a passion and a very specific problem. It's super hard to make an AI that solves generic problems. Most of them are hyper-specific. Now that I just talked about all the ways that AI sucks, what are some of the things it's actually good at? Well, like you might expect, it's really good at doing tedious tasks or things that have to do with really large data sets. That includes things like language processing, image processing, predictions based on history given like big sets of background data, and also deep learning and neural nets. When I talk about language processing, I'm not just talking about either text or speech-based language processing. Some AIs can also process code syntax. One of the really cool examples that I've come across is GitHub's Copilot AI. What Copilot does is it allows you to complete a stub of code and it will automatically fill in what it thinks you're trying to do. So it can auto-generate entire blocks of code for you depending on what you're trying to do. But don't worry, Copilot's not gonna take your job. Not now anyway, but it might make your hobby projects a little bit easier. AI is also really good at image and video processing. You see an example of this every day when Apple uses Face ID on iPhone. They use image processing and AI in order to determine whether it's the proper face that should be opening the screen on the device. You also see this used in cases like CCTV or airport security cameras to determine if people are high risk or a threat to public safety. But you also see this scattered amongst other applications. For example, you might be familiar with things like the CAPTCHA that you have to fill out. Click on how many things have stoplights in them, right? That's an example of an AI that classified a bunch of images with certain objects in them, and then they're challenging you as much as they are training their AI to be better at detecting items, as well as checking to see if you're actually a human. I personally think that deep learning and neural nets are the most exciting, but probably the most complicated part of AI today. Although there are a bunch of different types of neural nets, I think the two most exciting ones are both in the self-driving space. And these two things are really the only two self-driving software products worth even talking about. The first one is Tesla's full self-driving. Their beta version 10.1 just got released recently and will be continuing to roll out to new customers over the coming weeks. Watch this quick clip from AI Addict's YouTube channel.
We could go in the far right. There is a lane over there for us to go into. Doesn't seem to want to get us there, but let's see what happens now. It's green. We have a bicyclist. It's stopping for the bicyclist to text them. And there we go. Got over here. God, these Oakland roads are atrocious. So I have to go left of this light up here. Or the next light. My bad. So let's see if eventually it'll get us over to the left lane. And it does successfully get us over to this far left lane.
Now turn left onto Oak Street.
The other self-driving AI that I think is really cool is made by a company called Comma. And unlike Tesla, who has built in computers and cameras into all of their cars to enable full self-driving, Comma is trying to bring self-driving to vehicles that are not Teslas, even ones that don't have a lot of smarts in them. Basically, the minimum requirement is that your vehicle has an electronic steering system. The way that they do this is by mounting like a little Android-powered device with a front-facing and a rear-facing camera onto the dash, and then it connects to the OBD2 port in your car. Now, it doesn't support all cars right out of the box, but it is an open source project, so if you want to contribute to the project and add support for your vehicle, go ahead, nothing's stopping you. For very specific applications, AI is really good and can help you streamline specific processes. However, it's not a one-size-fits-all, single supercomputer AI kind of solution that some people think it is. A large majority of current AI projects that you hear large companies talking about is actually a misclassification of AI, and instead it's a complex event processing pipeline that they just think is really smart. Whew. So after all that, what do you think? Do you think that in 2022 AI is going to take over the world? Or do you think that we're still just going to be unlocking our iPhones with our face for the next decade? Thanks for watching, happy coding, and I'll see you in the next one.